So we have a hot air balloon along with its cargo has a certain mass and it holds this much amount of hot air. It's floating at a constant height in air with a density that's given. What's the density of the hot air in the balloon?
Cool. Hot air balloon. So what type of question is this? Wow, way to be super loud.
Did I sign up for you today?
Yeah.
I thought you weren't doing anything this week. I thought it was the other guy.
Yeah, it wasn't put in until yesterday because I didn't realize that I didn't have any hours posted. And then yesterday.
So you have hours posted now?
Yeah, the regular ones.
Okay. Let's go back through. What are you doing?
I'm just doing test corrections.
Okay. Sweet.
We're doing the hot air balloon one. Have you got that one?
Yeah, I'm done with that. I'm in the last two, and that's it. Do the hot air balloon before, I think, with you earlier.
Oh,
Yeah. That
cool.
was with you.
Then I'll know how to do it. I don't remember.
Maybe. We'll see.
We can assume then we can do the other two that you need.
Cool. So it's number 16. So
Yeah.
hot air balloon along with its cargo. Oh, I do remember this one. Has a mass of 4.0 times 10 to the 5 kilograms and holds that much air. It is floating at a constant height in the air with a density of 1.29 kilograms per meter cubed. What is the density of hot air in the balloon? So let's go ahead and draw a picture. Okay. So if it's floating at a constant height, what does that tell us about the up and the downward forces?
The up is greater because it's constantly moving up.
No, it's floating at a constant height, so it's
Then they're equal.
perfect. Yep, so it's just staying in the same spot, which means our upward force.
My downward force are the same.
Exactly. So what is giving us a downward force?
The force of gravity.
Good. So force of gravity, which we know is equal to m times g. What's giving us our upward force?
The hot air in the balloon.
Yeah, so what type of force is acting on the hot air? The hot air inside the balloon is less dense than the air outside of the balloon. So it's kind of weird, we don't usually think about this type of force acting in the air like this, but this is buoyant force.
Okay.
So usually we think of buoyant force in water
Water.
and stuff floats. But we can totally have a buoyant force in any fluid, and air, or atmosphere, is a fluid because gases and liquids are all considered fluids.
Okay.
So we've got buoyant force up here holding the balloon up. And so we know that buoyant force is going to be equal to the mass of air, which is being displaced, times gravity. Now another way that we can write that is by saying the density of air times the volume of air times gravity. And we know the density of air from the question. What number did it give us?
1.29.
Yep.
So we know it's 1.29 kilograms per cubic meter.
Mm-hmm.
The velocity of air is going to be the same, or not the velocity, the volume of air is going to be the same as the volume of our balloon, which is also given to us.
7 times 10 to the 5th. So that volume is displaced, right? Displaced volume. So the buoyant force is displaced volume.
Yeah, so it's,
Okay.
buoyant force is always equal to however much fluid we're displacing times gravity. So if we know the mass of fluid that's being displaced, we can just go straight for this. But a lot of times we don't know that, so we take this approach where we say the density of the fluid times the volume of displaced fluid times gravity, because density times volume gives us mass.
Okay.
So it's the same thing, just written in a different way.
Okay.
So then the last thing that we need is,
9.8.
good, 9.8. So that will give us the buoyant force.
We're trying to figure out the mass, right? The density.
And the density of the hot air.
So mass times gravity. Has to equal that.
So did you get,
8849,400. Yep.
cool. So 8,494,000. So a lot of newtons.
Yeah.
So we already said it to begin with that this force, the upward force, needs to equal this downward force.
Mm-hmm.
So now, this number we know needs to show up down here as the force of gravity. So we've got mass. We don't know what the mass of everything is. And this is where I think I got confused the first time I worked through it. Because they give us a number for mass, but that's just the mass of like the basket and the cargo and the shell of the balloon, but it's not including the mass of the hot air. So we're looking for the total mass of everything, cargo, basket, and hot air, everything combined. So we're gonna say M times 9.8 needs to equal this number. So we just end up dividing it by 9.8. We find out that the mass of everything is 903. Good, kilograms. So now,
You just have to subtract the other mass that was given to
Good.
us from that.
and that way we'll isolate just the mass of the hot air. So what was that number?
4.0 times 10 to the 5th.
So I got 503,000 kilograms. Great, so now we're pretty much home free. The last thing we need to do is to find density of our hot air. We just need a mass over a volume. So we know what the mass is. It's 503,000 kilograms. The volume was that 7.0 times 10 to the 5th meters cubed. We got 0.719 or 0.72. Yep. That's it.
Okay.
So kind of a cool question. Anything that didn't make sense?
No. I think I got it.
Nice. Cool.
Yeah. Thank you.
No problem.